So, today we're looking into the circular motion. First question. When we have, for example, car moving in a circle, which force actually make it to turn? Why it's moving in a circle? Which force turning car around?
The wheels?
Is wheels a force or object?
True.
Okay, now I will now rotate this thing. I'm rotating it slowly, and car stay where it is, rotate with the tail. But what will happen is if I will rotate it fast? It falls. Why it was staying here and rotating with the table when it was done slowly, then why it, when it was rotated fast, it went off. What was holding? Yes?
Because the rotational force is lesser than the frictional force.
What is the rotational force? Which force acted? Torque. Okay, so what was turning car around when car just driving? It's a friction force. Think, remove friction, put car on the ice. Will you be able to turn on the ice? No. Here, because friction force, that's what was keeping now car moving in a circle with the table. And that friction force keeping there. But friction force can be only that much. It depends on the materials of the surface and the wheels. So when I start rotating it fast, friction force not enough to keep it.
Why is that? Why is that? That the friction is when you
Friction force is determined by the wheels and the surface. And it can be only that much. It cannot be more for certain surface and certain wheels, it cannot be more than much. But to turn the car around, it needs to be, if it's turning fast, it needs to require more force. And it's not enough, so it slides away. And this is one of the most important things that you need to get of your study of physics course. When you will be driving, never do sharp turns fast. Because what will happen if you do sharp turn fast? You will slide away from them. So this is one of the most important knowledge that I hope you will get out of your physics course. Never do fast, sharp turns. Because that's the way to slide away from the way you're turning and get into the inside. Now, let's now consider some theory. And we consider horizontal motion, circular motion first. We will then consider vertical motion a little bit later on, but let's start from horizontal. So we have object moving in a circle with a constant speed. Speed constant. Is velocity constant?
No.
Correct. Why? No.
Because the speed's constant. Because it's constantly moving in a different direction.
Because direction change, velocity has direction, and direction all the time change. Here, it's this way. Here, this way. Here, this way. Here, this way. It's all different velocities. If direction change, velocity change. So this is a motion with acceleration. As soon as velocity changes, it's a motion with acceleration. And if speed constant, and we have the radius of the circle R, it can be shown that acceleration will be v squared over R. The deriving of this formula is not in the course, some will be interested in show, but it just can be derived just from the similar triangles. But it's not in the course, so I'm not deriving, I'm giving you it straight. And direction of this acceleration will be all the time at the right angle to the velocity. Why it has to be at the right angle?
That's towards the radius.
To the center, but why it has to be, why? What will happen if it will not be at 90 degrees? What will happen with the speed? What will happen with the speed? Speed will not be constant. If there will be component of the acceleration along the velocity, not only direction will be changing, but the speed. But as this angle is 90 degrees, speed, so magnitude of velocity does not change, but direction changes all the time. And that directed to the center, that's why it's called centripetal acceleration. It's called centripetal acceleration. So we have little c, centripetal acceleration. And according to second Newton's law, force equal ma, so you'll have the net force equal mv squared over r. mv squared over r. And this force called centripetal force because it's directed to the center. And now very important thing. There is no such force as centripetal force in the nature. There is no such force. What it is? Net force. If it happens that the net force, so sum of actual forces acting on the object, is constant and at the right angle to velocity, there will be motion, will be circular motion with a constant speed. Make a note. Two conditions for the circular motion with a constant speed. First, net force constant, F net constant in magnitude, constant in magnitude. Second, F net perpendicular to velocity. This is two conditions to have circular motion, motion in a circle with a constant speed. And then with students, they will be highly likely to have an exam questions to explain something related to it. And what student often, this one student often, right, this most forget. It must be constant magnitude. So, different forces can play a role of the centripetal force. When car turning, which force turning it? Action force. Friction force. So the friction force acts as a centripetal force. But there is no such force, centripetal force. There is no such force in nature. It's net force. It's the sum of the different forces acting on the object. Let's consider another circular, horizontal circular motion. If we will have horizontal pendulum, so we have some mass and rotating in a circle, and we have angle theta, and the length of the string is L. And it's rotating like this. It's rotating like this. So what I mean horizontal circle? If I have this, say some any mass, and it's rotating horizontal circle like this. It's moving at the horizontal circle with the same angle all the time, moving with a constant speed. This is what I'm saying, the horizontal pendulum. It's not the same. We'll look later on if I will make it like this. It's not at the same height. Or if I will rotate it like this, if I will rotate it like this, that is completely different. It's a vertical circle. We'll consider this a little bit later today. But now we're looking horizontal motion like this. We disregard obviously a resistance. So which force is acting on this mass? Which force, when it's rotate like this,
mg.
we have weight force of gravity, we have mg. What else is weight acting? Tension. We have tension. Is there any other forces acting? No. So to solve this situation, we need to follow the same steps as we're doing when we're solving equations with the forces. We choose axis because we have two-dimensional motion. We have one this way and y vertical. What is the and let's find what will be the radius of the circle. What will be the radius of the circle? This is L and angle theta. Come on, basic trigonometry. This L and this L theta. What is the radius of the circle?
L sine.
L sine theta. So we have now what will be acting horizontally. What will be does mg has any component acting horizontally? No. Tension. What will be the component of the tension in the horizontal? T sine theta. So the only force acting horizontally is T sine theta. So that what will be centripetal force, that what makes it's moving in a circle. So that is mv squared over r, centripetal force. Because it's moving at a constant speed, so net force has to be directed to the center of the circle. So T sine theta equals mv squared on r. That in the x direction. Now, what we will have in the y direction? Which force is acting in the y direction? What's acting up? Not all tension. What component of the tension? T cos theta. What's acting down? Mg. And because it's at the same level all the time, what will be the resultant force horizontally? 0. That's equal 0. I will rewrite this as T cos theta equal mg. So you have equation 1, equation 2. Let's divide equation 1, divide by equation 2. What will happen? Tension cancels out, sine divided by cos is tan theta equal, mass cancels out, and we have v squared over g. We will see that this formula will be coming up in different scenarios few more times. Same for different scenarios, but we will be ending up with the same formula. So this is the relation between the speed, radius of the circle, g and n at which it's. Make sense? What we did. Let's have a look now. That's the horizontal. Let's have a look into the verticals. And with the vertical circles, it is slightly different because we doing assumption that the speed in the vertical circle is constant. But can it be actually constant? Can the speed be constant when it's moving in a vertical circle? Why not?
Without the top.
No.
It changes. The jig head changes. Energy.
At the top, what energy? Let's take this as a very bottom.
Gravitation.
At the top, it has gravitational potential and kinetic. At the bottom only kinetic, law of the conservation of energy. It cannot be same speed here and here. It's impossible. Weight will be moving faster.
Top.
The bottom. Because here some energy is gravitational potential and kinetic. Here only kinetic. But sometimes you will be asked to find this speed at the bottom, but generally saying, in most of the cases, we consider, for simplicity sake, that it's same speed, which is impossible. It is impossible to have same speed at the top of the circle and bottom. So and we're not looking into any other cases except when it is moving vertically, except the very top and very bottom position. We're not considering any positions in between. So mathematics, they think it's too hard for you guys. So at the top, which forces acting at the top?
MJ.
Yes? What else? Forces, what else? It's on the string, it's on the tension. As soon as string involved, it has to be tension. And we choose put direction down, and we'll have T plus mg. And as it's circular motion, it has to be equal what? mv squared on r. So what tension equal at the top? mv squared on r minus mg. Now, at the bottom, what happens at the bottom? Which forces acting at the bottom? Only? What happens with the gravity? Who removed it? And how?
Why is it just J?
And there is still mg.
Yeah, but
Gravity acting always. You need to go away from the earth to not feel its gravity. Yes?
Why is it?
Just minus J, not minus J.
Huh?
Why is it just J?
Okay.
Oh, okay.
Because I lost letter M. So, now let's choose direction up. As it moving in a circle, acceleration, so net force has to be toward the center. So we have now T minus mg equal mv squared on r. So that tension top, that tension bottom. So from here we get tension at the bottom equal mv squared on r plus mg. So where tension is greater? At the bottom or top? Bottom. So if this string will break during the rotation, it will rotate too fast, and weight will break most likely at the top or bottom. If it breaks more likely at the bottom. Make sense? Now let's consider another kind of vertical motion when we have a car moving over the bridge. Can I clean it up? Car moving over the bridge. And again, we consider only situation at the very top of the bridge. And we consider that the bridge is a part of the circle. It's perfectly circular form with the radius r. Which force is acting on the car at the top? mg, what else? A normal reaction. mg, and we have normal. In which direction will be net force directed? It's moving in a circle, so where it should be directed? to the center. Direction when you're moving in a circle, net force to the center. So we'll be vertically down. Makes sense that it has to be directed to the center. So we choose positive down, we get mg minus n, and always net force, when it's motion in a circle, is mv squared over r. Now, if car moving fast enough, so from both n from here equal, n equal mg minus mv squared on r. If we will start increasing speed, rough, got a new first car, and want to go a bridge fast, what will happen when we increase v?
It'll jump and fly.
What happens to the normal reaction eventually?
It's larger than
What happens to normal reaction? It becomes smaller and it becomes zero. What does it mean if normal reaction is zero? It's lost contact. It's flying. It's flying. So again, don't go fast over the bumps or bridge because you might lose contact. It's like so. If you take n equals 0, does it make sense that if speed increases, you might lose contact? If n becomes normal reaction 0, you don't have a contact. You fly. Yes.
Why is it when n's lower that it's like flying?
If now, when you're sitting on the chair, yeah, what do you feel?
Chair?
Which force you feel?
The normal?
Normal force.
Yeah. So
If normal disappear, means you don't have a contact with the chair.
would I sink? Would I fly?
You know how you can have a normal when you're sitting on the chair. You know what we should do? We can do. If we put you on the chair, and then we drop you together with the chair. During the flight, there will be no normal reaction. There will be no normal reaction while it's until it hit the floor again. So n equals 0, we get mg equal mv squared on r. Mass cancels out and we get maximum speed with which you can safely go over the bridge equal v max squared equal gr. So that's the maximum speed. If you move faster than that, you go, you fly. Make sense how we got this? Okay. Now, if car going through the deep, like this, here, which force is acting? Still have same forces, mg, and we have n. Which direction will be accelerate, net force acting and acceleration? Vertically up. So we'll have now n minus mg equal mv squared on r. So n equal mg plus mv squared on r. So you will feel heavier at the bottom. And you feel lighter because what we feel normal reaction. And that's next Tuesday when you go to when we go on the excursion to Luna Park, you will experience by yourself. And you will need to make a note of that. Where you feel heavier, where you feel lighter. Regarding all those details as before, how much details you will need to get from your excursion. Make sense? Now, one more situation in the motion, such type of motion. When you're going under the bridge, have you seen at least on the video, the stunt when the motorcycle going in the sphere and going underneath? Have you seen that?
Yes.
Now let's consider this situation and how it's possible. How it's possible.
Velocity.
No, we'll explain why, but it's all physics. As usually, if there is reason behind something, it's usually physics. So we have mg, and what will be the direction of the normal reaction?
Same as MG.
Hmm?
It's the same.
Same as mg, down, because it is at the top, the surface is at the top, n. And we have n plus mg equal mv squared on r. So n equal mv squared over r minus mg. In this case, as fast as you're moving, the bigger normal reaction. Now, what does it mean that it has normal reaction?
You stuck on the surface.
Because you pushing on it, you pushing on the surface, it pushes on you. So as fast as you're moving, the more you push it on the surface. Let's consider a situation when it's like just make it. So we take n equals 0. N equals 0, we get the same formula. V squared equal gr. But that will be minimum, not maximum speed. That will be minimum speed to make it happen. That will be minimum speed to make it happen.
What about for
And
what
now, there was a question on the exam, I think twice over years. Explain why car not falling down. Why car or motorcycle not falling down. And the way explanation that normal reaction is not zero, that speed is greater than minimum required, and so on, which is pretty much explain what happens. But what is the actual? And the examiners didn't ask to, and very small number of students actually answered the proper answer, but the proper answer it was considered talking about n, minimum speed, and so on. But what actually which physics law keep motorcycle there, not falling down?
Newton's third law.
No. But you're thinking, but close, but close.
First law.
Newton's first law, yes. Newton's first law. If, what the direction of the velocity here?
Down. No.
Velocity,
Sine.
this way. If there will be no this rail or whatever it is, what will happen? How it will go?
Fly.
Fly there and then become a projectile. But it will not turn this way. So it's an actual reason is the first Newton law. It's inertia. And as a result of that inertia, it pushes on the thing and keep moving. Yes?
But if you said n equals 0 for the other diagram.
Yes? N equals 0 means we're losing contact. Just losing contact.
No, I meant like you put n equals 0 for this diagram. What about the other one where it gives? Like,
Which one?
This velocity is constant.
Can be N 0.
no, because
N cannot be in this situation, N cannot be 0. Because mg plus mv squared on r. As fast as you're moving, the heavier you will feel. And the last thing, today I want to just give you a lot of theory. We'll start practicing questions tomorrow after my test. Last situation that we have not covered. Bent rod. Bent rod. I don't know, have you noticed that, for example, on freeways, on the highways, on the turns, the road is not flat. It's at the end. Have someone noticed that? Why is that? Why the road made not flat? They made at certain angles. Why it makes the same?
Pushes in the direction of the turn.
That is to help to include normal reaction to contribute to the centripetal force. So let's consider car is here, but it's moving not along. Before we were considering motion along the inclined plane up and down. Now we consider it's moving like this in a circle. So it velocity out of the ball, and it's made. Remember, have you seen like those NASCAR races?
Yeah.
That's or velodrome where they're moving in a circle. That's the situation is. So it's moving like this. Which force is acting here?
MJ?
Yeah. And
Normal.
normal. And we consider if it's turning, how turning without help of friction. So when before we were dealing with the inclined plane, how we were choosing the axis? How along the plane and perpendicular. In this case, no. We will choose axis this way, x, and y this way. Why is that? What will be the, if it's moving in a circle, what will be the direction of the acceleration? What the center?
Yeah.
Center is here. It's moving at the same height. So that is direction of acceleration. So if this angle is theta, then this angle will be theta, and this angle will be theta. So what will be the resolution of the forces in x direction? What's acting in x direction? Come on, basic trigonometry. X direction. Is mg acting horizontally? No. What will be the, this is angle theta, as you can see. This is theta as alternate angle, and so will be this 90 minus theta, so this is theta.
And sine theta.
Yes, and sine theta. And what it should be equal?
MV squared on R.
mv squared and r, net force. In y direction, we will have that n cos. If in x it's sine, obviously, even if you don't know trigonometry, it's easy to guess that then it has to be other one. Cos will be minus mg equals 0. Or, I will write that n cos theta equals mg. And that's equation 1, equation 2. What we should do now? Divide. N cancels out. And we have formula that we've seen before. Tan theta equal v squared over g. And what making it turn? Normal reaction. Which if wrote flat, normal reaction does not contribute to the turn. I think I gave a lot of theory today. Need some time to let's set it down. So that's all explanations for today. To like, subscribe, and donate to help fight Russian aggression, support Ukraine and Israel.